Hello everyone, you're welcome to another class on mensuration. Okay, I want to greet everyone. Today we are going to continue from where we stopped in the last class. Okay, don't forget in the last class we looked at circle and the properties of circle. Don't forget we were able to define what center of a circle is. We said center of a circle is the middle of the circle, and we also talked about the radius of a circle as the shortest distance between the center of the circle and any part of the circumference. Why we said circumference of a circle is the boundary or the length of the boundary of the circle. And also we looked at diameter. We said diameter is a straight line that's cut the circle into two equal parts. I want to believe you still remember that, okay? So, and we said diameter is also the same thing as 2 radii because, when you add 2 radii together, it gives you diameter. Similarly, we looked at a chord. We said a chord is also a special diameter. It's a special diameter. It doesn't pass through the center of the circle, diameter passes through the center of the circle. Why chord doesn't? So, or we say the chord divides the circle into two unequal parts. So, or we say the chord divides the circle into two segments, major and minor segment. Okay, all right. And we also looked at segments. We looked at the perimeter of the segments. Don't forget we said a segment looks like this. And then when we want to find the perimeter of a segment, we want to get the length of the chord plus the length of the arc. And I think we also looked at length of arc. We said an arc is a fraction of circumference of a circle. So if I know the formula for calculating circumference of a circle, I will find it very easy now to know what length of an arc is, because an arc is a fraction of perimeter of a circle. And we also said that we have two types of arc. We have major arc and the minor arc. All right. So also, what do we look at? I think that is all. And also, we looked at the perimeter of a sector. Yes, we looked at perimeter of a sector. We said, okay, perimeter of a sector of this form. Now we said, now you have to add the three parts, which is three parts of a sector. Now this is a radius, this is another radius, and this is an arc. So you add two radii together plus length of an arc. That gives you the perimeter of a segment. I think that was where we stopped the last time, and I promise you that I'm going to also explain to you how to find area of a segment. Area of a segment. So we are going to derive that formula today before we begin the class. Now, before we start, I want you to kindly inform your friends, let them know the class has started, and don't forget the like button. And if you are new on this channel, please try as much as possible to click on the subscription button so that you'll be notified anytime we are on air. All right. Okay, so get your writing materials ready because this class is going to be interactive as usual. All right. And don't forget to invite your friends. Just share this link with your friends. Let them be aware of this class. All right. Let's see those that are around. If you are around, I want you to say hi. Just say hi so that we know the number of people that are around. Okay, I think I can see Toyosi. You are welcome to class. Divine, you're welcome to class. Okay, Makinde, you are also welcome to class. Who else? Who else? Okay, say hi so that I see you. Okay, I think I can see Abbas now. Abbas, you're welcome to class. As you are joining the class, make sure you tap the like button. Okay, show me there. You're welcome to class. It has been a long time. Okay, who else is in the class? All right. Any other person? Okay. 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 I'm also seeing Abbas. All right. Okay, Riscott, you are welcome to class. I can see you here. All right, so once you join the class, ensure you just say hi so that I know those. Okay, Pamela, it's been a while. Okay, you're welcome to class. All right, so as I join the class, make sure you tap the like button so we know those that are in the class for today's class. Okay, all right. Okay, as you are joining, make sure you say hi so we know those of you that are available for today's class. All right, now let us swing into action because we don't really have much time. Um, Now, I've given a recap of what we did in the last class. So now, if this is a circle and we have two radii of this form, this is radius, this another radius, and there is a chord here. This is a chord. Okay. Now, we have a minor segment. So how do we get area of this minor segment? Now, what I'm going to do now, let me bring out this sector out. Okay. So this is the center of the circle. This radius 1 and 2. All right. Now, if I want to get the area of this segment, now what I just need to do is that out of this sector, take away this triangle. You can see we have triangle. Let me label this place AB. We have triangle OAB. So take away this triangle AOB. So you'll be left with this one. All right. So out of the whole sector, this is a whole sector. All right, I want to get this area of segments. So take away this triangle from everything. What you are left with is this segment. Okay, so now can I generate a formula for that now? So you can see what we did now. We said sector, a whole sector minus the triangle. It gives us area of segments. I hope you understand that. Sector, area of sector minus area of triangle gives us area of segments. So now this is the formula now. Area of segments is equals to area of sector minus area of triangle. Okay, so that gives us theta over 360 times pi r squared. Don't forget, this is the formula for finding area of the sector. I hope you have that in your jotter. So minus area of triangle half r squared sine theta. Okay, so this is the formula for finding area of the segment. Don't forget, now this is the formula for finding area of triangle. You remember I told you when we were looking at area of triangle that we have A to be equals to BC or AC rather, AC sine B. All right. So in this case now, side A and side C is R. Okay. So A is R and C is R. So the angle B here now is the theta that we have in this angle here, angle subtended at the center of the circle. All right. So that is what we have. So now in your jotter, also add this to the formulas you have. So if you are not in the last class, I'm going to advise you now try and go through my previous video, right? So I've given you all the formulas that is needed. Okay, we have a lot of formulas, so you don't need to cram them. Make sure you understand how those formulas are derived. Okay, so let us start with some examples. Let's start with the first example for today. Example 1. An arc subtends an angle 60 degrees at the center at the center of a circle of radius 14 centimeter. Find the length of the arc if pi equals to 22/7. Okay, this is a very simple question, and I want us to solve this problem. Now let's look at the question. Now the question says an arc subtend an angle 60 degrees at the center of a circle. You see, arc subtend an angle at the center, chord also subtend angle at the center. All right, so now let's look at it. We have a circle of this form. Okay, so let's say we have this arc now. Let's say it's arc AB. Don't forget what we call arc. Arc is a fraction of perimeter of a circle. Now this is the arc we're talking about here. Okay. Now this arc subtend an angle at the center of the circle. Now let's say the center is O. Now the angle subtended is 60 degrees according to the question. All right. So now at the center of the circle, radius 14 centimeter. The radius is 14. So that means this place is 14 centimeter. Now the question now is find the length of the arc if pi is 22/7. So how do we solve this problem? The first thing that comes to mind is formula for calculating length of an arc. I will quickly remember that an arc is a fraction of perimeter of a circle. Now I need to recall what is the formula for calculating perimeter of a circle. That is 2 pi r. All right. So since an arc is a fraction of it, so now length of an arc is going to be theta over 360 times 2 pi r. All right, so you can see I don't need to memorize a formula, so I can always derive my formula easily. All right, so this is the formula for calculating length of an arc AB. So we now say AB, length AB is the angle is 60 over 360 times 2 times 22/7 times 14. R is 14. Okay, so now in this case, now you can see 0 cancel 0, 6 goes here 1, 6 goes here 6. Now 2 goes here is 3, 2 goes here is 1. All right, 7 goes here is 1, 7 goes here is 2. So we have AB to be equals to, now what do we have in the numerator? We have 1 times 1 times 2. Okay, times 22 times 2. Everything all over 3 times 1. So we have 3 times 1. So AB, length AB, length AB equals to 44/3. So, and that gives us what? 3 goes in 4, that's 1, remainder 1. 3 goes in 14, that is what? That's 4. It remains 2/3. So this is going to be in centimeter, or I say AB will be 14.67 centimeter in decimal. So this is the answer to the problem. Okay, so that is how to calculate length of an arc of a circle. All right, so before I move down to the next question, is anyone that have a question, or if you really understand, so please, I want you to drop that in the comment section so that I want everybody to be carried along. So is there any reservation? Let me have your impression about that question I just solved before we solve the next question. Yes. Any question based on what we have done? Okay, so if there is no question, now let us look at the next question I have here. Example 2. In terms of pi, what is the length of an arc which subtends an angle Okay, yes. Now, before we solve the next question, don't forget, if you are new on this channel, ensure you tap the subscription button. And don't forget to also like this video if you actually enjoy what we are doing here. All right, now let's look at this question. Now, in terms of pi, what is the length of an arc which subtends an angle 30 degrees at the center of a circle of radius 3.5 centimeter? Okay, so now I need to take note of this. My answer should be in terms of pi. So I should not assume pi to be 22/7. That's the negation of this statement. So let's take note of that. Now, the question wants me to get length of an arc. All right. So I don't have any problem. All I just need to do is just to write out the formula and substitute. Now, but before I substitute, now let's get the angle subtended. Angle subtended at the center of the circle is 30 degrees. Okay. Now, what is the radius? The radius is 3 whole number 1/2, 3 whole number 1/2. And that's the same thing as 7/2. Okay. All right. So what other information do we have? We have pi to be pi. So we have now length of arc. So length of arc equals to theta over 360 times 2 pi r times the circumference of the circle. All right, so let's plug in the values. Now we have theta is what? 30 over 360 times 2 times pi times 7/2. I hope you understand that. All right, so now let's try and simplify. Now 0 cancels 0, 3 goes there 1, 3 goes there is 12. Okay, so 2 cancel 2 here. All right, so what we have here now is what? Now use this 1 times pi times 7/12 times 1. Okay, this is 1 here. So we have 7 pi over 12 centimeter. So this is the length of the arc in terms of pi. You can see our answer is in terms of pi. So this is the length of arc. All right. I want to believe you all get that. All right. So now I'm moving to the next question. Is there any observation based on what we have done? Any question? So I want to know if we can move forward. Yes. We all get the explanation to that. All right, if there's no observation, no question, let's move down to the next example. Example 3. All right, so now let's look at the next question. The question says, what angle does an arc 5.5 centimeter in length obtain at the center of a circle of diameter 7 centimeter? Okay, so I want to believe you get the question. So now let us solve this problem. Let's do it individually, and let's drop our answer in the comment section. So I will be giving you like 2 minutes to attend to this question. Just follow the step I gave you the other time, so you'll be able to solve this conveniently. So try this and let's see what you have. So try the problem and drop your answer in the comment section. So I will be waiting for Theos' answer, Riscott answer, Moturayo. Okay, I'm just seeing you for the first time. Okay. Yes, you're welcome to class. Adepoju, you're welcome to class. All right. I'm just seeing you. As I'm joining the class, make sure you tap the like button. Okay. All right. So try the problem. Let's see what you have for that. Okay, by now we should be running up. So if you have the answer to the problem, drop it in the comment section. I hope the question is not difficult. Yes, is anybody with the answer? Nobody is giving us an answer. Oh. All right. We may have to solve the problem together because of our time. So time is not on our side. Okay. All right. Now let's solve the problem together. I want you to pay attention to this question. So after solving this, the next question I'm going to ask you to solve. So everybody should be able to do that within a very short time. Now let's look at what we have. What angle does an arc 5.5 centimeter in length subtends at the center of the circle of diameter 7 centimeter? Now, what is the question talking about? It's asking about the angle subtended by an arc. Now let's look at the circle. We have a circle of this form. Now this is the center. O. Okay. So now the length of this arc is given to be 5.5 centimeter. Okay. So now the question is, what is the angle subtended by this arc AB at the center of the circle? All right. Now, when you look at it, we are not giving the radius. What we are giving is what? The diameter. So you know the relationship between radius and diameter. I told you that diameter equals to 2 radii. All right. So that means that we have 7 equals to 2 radii. So 1 radius is 7/2. So that's going to be in centimeter. So that means the radius is 7/2 centimeters. So let's look at it. 7/2 centimeter. Okay, so now is there anybody with the answer now before I will start? Any person? Okay, nobody. All right. So now let's go on. Now, what we just need, because the question is talking about length of an arc, so we need to write the formula for finding length of an arc. So we now say arc AB equals to theta over 360 times the perimeter of a circle, that is 2 pi r. Perimeter of a circle, 2 pi r, because an arc is a fraction of perimeter of a circle. So I want that thing to sink into your brain. So you don't need to cram any formula. Once I just remember formula for calculating perimeter of a circle, so I must know length of an arc easily. So now the length AB has been given to be 5.5. Okay, and I'm looking for theta here over 360 times 2 times 22/7 as pi times 7/2. Can you see that now? All right. We have to be very careful when simplifying. Here. So when you divide this by 2, you have 1. This by 2, you have 11. Okay, so this equation turns to 5.5 equals to, now that is 11 theta over 180. Do you get that now? So what do we do next? We cross multiply. Let's cross multiply. So this is over 1. So you can cross multiply. You have 11 theta equals to 5.5 times 180. Okay, so now this is the same thing as 11 theta equals to 55 times 18. All right, once you move the point to the back, so this 0 leaves, we have theta equals to 55 times 18 over 11. You divide both sides by 11. Okay, so we have theta equals to, now 11 goes here is 1. 11 goes here is 5. Okay, I hope that is correct. So we now have 5 times 18. 5 times 18. So now what would that give us? What is 5 times 8? That is 40. We write 0. 5 times 4, that is 9. 5 plus 4, that's 9. So we have 90 degrees. So that is the angle subtended at the center of the circle. Okay, so that is the angle subtended at the center of the circle. Yes, we are moving to the next thing. So any question based on what we have just done, any reservation, any observation, right? So if you have, I want you to drop that in the comment section. Let's see what we have. So if there's any question, let me have your impression about the example we just did now. And don't forget, if you are just joining, make sure you tap the like button. If you're new, you ensure that you subscribe to the channel. All right. Okay. Thank you, Infinity. All right. Thank you. All right. Okay. So I think some of us are saying we are good to go. We are good to go. Yeah. Muturayo. Okay. All right. So Toyosi said, I got it. Okay. All right. That's good. That's good. That's good. Okay. So, all right. Divine, you're welcome. All right. Okay. From India. Okay. Infinity, you're welcome from India. All right. Okay. That's good. You are highly welcome. All right. Okay. Yes. I think we can now move down to the next question. Now let's move down to the next question. Example 4. I want you to pay attention to this next example. So before I solve the question for you, you are going to make an attempt, right? You make an attempt before I solve the problem. All right, so let's see. A wheel radius 14 centimeters rotates Okay, so now let's look at this problem. This is a real life problem. Real life problem. Now, a wheel of a radius 14 centimeter rotates through an angle 135 degrees. You have to find the distance traveled by a point on the ring. Okay, this is a very interesting question. So can we try that? Now let's link it with what we have been doing. All right, this is a real life problem. So this one is not abstract like the ones we have been doing before. All right, so what is going to be the distance traveled by a point on the rail? Okay, now let me just give you like 2 minutes to attend to that. So after which we are going to solve the problem together. So while you are doing that, if you are yet to tap the like button, please ensure you do that. New members, new viewers should ensure to click on the subscription button so you'll be notified anytime we're on here. Right? So you have 2 minutes to attend to that problem. Let's see what okay, is this the answer Infinity is giving now to this question? I can see 32.97. Is that for this example or for the previous one we did? Okay, all right, thank you for this. Yes, that's very good. All right, now can we wait for others? Let's wait for others to give their results. So make sure you are doing something. Make sure you are doing something. It doesn't really matter if you get the answer, just make sure you make an attempt. That is the best way to improve. Okay. So I want to believe you guys are working. So I'm waiting for show me this answer. I'm waiting for Riscott's answer. Yes. Okay, you're asking for the answer now. Let's wait. Let others drop their answer. Okay, so I want every one of you to try, and I'm going to solve it together. We are going to solve it together. So let's just exercise patience. Let's wait for others to drop their answer if we have any. Okay. All right, that's good. Okay. Muturayo, I'm waiting for your answer. Familiarly, I'm waiting for your answer, and others. Okay, we don't really have much time. So we are going to solve the problem together now. So since it's just only one person that dropped an answer. So now let us see how are we expected to solve this problem. Let's see maybe what Infinity gave us is correct. So if that is correct, so we have to give him a round of applause. That's very smart. Okay, so now let's see. Now, a wheel of radius 14 centimeter rotates through an angle of 135 degrees. Find the distance traveled by a point on the rim. So now look at it. A rim looks like this, a wheel rather. So now there is a point here. Now don't forget the wheel have a center and a circular in form. So now, and we have a radius. So it looks like this. Now we are told now that this wheel moves, it rotates, okay? It rotates through an angle 135 degrees. So that means from this point A, where the wheel starts from, it moves down until it covers an angle of 135 degrees. I hope you understand that. So this is going to be B. Now the question wants us to know how far a point on the rail has traveled. Okay, all right. You know, if it's going to move, it's going to move this distance. This distance, the length of the arc is going to move from here. This is the starting point, and it's ending here because it has moved for this angle. So this is going to be the distance covered by a point starting from here. So now that means the length of our arc is what we are looking for. And that is the same thing as the distance covered by this wheel. by a point on the rim. Okay, so now let us now calculate this length of arc. Don't forget, the radius has been given. What is the radius? Now the radius is 14. So let's write that here. We have 14 centimeters. So we just have AB, that is the distance AB covered by the wheel is going to be theta over 360 times perimeter of the circle. Okay, so that is going to be 2 pi r. All right, so that gives us what? 135 over 360 times 2 times 22 over 7 times 14, which is the radius. So we just plug in this, and pi is the same thing as 22 over 7. Theta, the angle given. So now let us find a way of simplifying this. Now see, 7 goes here 1, 7 goes here is 2. Now let me reduce this. Now 2 goes here is what? 180. 2 goes here is 1. 2 goes here is 90. Okay, and 2 goes here is 1. Now 2 goes here is what? 45. 2 goes here is 11. Now let's see. Now 5 goes here. That's going to give us 9. Okay, 5 goes here is going to be 20 what? So 5 goes in 13, that is 2. Remainder 3 in 35, that's 7, 27. Now 9 goes here 1. 9 goes here 3. Can you see that? So we have 3 here. So now our answer now will be, we have 3 here. We have 3 times 11. What else? Times 1. Okay. So everything all over what? We have 1. We have already exhausted everything. So 1 times 1. So that's all. So now, and that gives us what? So when you multiply, we have 363 centimeter. So that's what we're going to have. 363 centimeter once you use this to multiply this. So this is the answer to the problem. So this is the distance covered by the wheel, okay, or by a point on the rim. So this is going to be the distance covered. So I want to believe we are on the same page and nothing is missing out. Okay, so any reservation, any observation, okay, please drop that in the comment section. Let's see what we have. Do you understand that? Yes, infinity, what is it? Any observation? Toyosi and others, yes. Okay, it should be 3 times 11 and not 33. Okay, I think I can see that. So, all right. So that means we have 33. All right. Okay. Yeah. Thank you. Thank you for that. So that is 33 centimeter. Okay. All right. Thank you. So we have 33. 33. So that's going to be 33 centimeter. So yes. How far? All right. Okay. So that's 33. All right. Okay. Good. Good. So it shows that every one of us are in the class. Okay, thank you. Thank you. Thank you. Okay, okay. Yes, can we now move down to this next one? Honestly, this next question, every one of you must get the answer to this problem. So nobody got the previous answer. Nobody got it. So, but infinity try anyway. So, but this time around, I want every one of you to get the answer. Let's see the first person that is going to give us the results. So before we solve it together, okay, example 5. So an arc and arc is 3/8 of the circumference of a circle of radius 28 centimeter. Now find Roman numeral 1, the length of the arc, and Roman numeral 2, the angle subtended at the center. Okay, so that is the question. This is a WAEC question. Okay, now let's see those that will give us the answer to that problem before we solve it together. So like I used to say, make sure you make an attempt. Don't just assume that you can't solve the problem. So you have to ruminate on it, look at the question, read it and see. Just make an attempt. Even if you didn't get it, making an attempt is half solved. All right, so an arc is 3/8 of the circumference of a circle of radius 28 centimeter. So the question says, find the length of the arc, and 2, the angle subtended at the center. So that is that. So once you have your answer, please drop in the comment section. Yes, drop your answer in the comment section before we solve together. Okay. So I'll be waiting for infinity answer this time around. So I'm very sure we should have a positive answer this time around because you have been making an attempt. That's very good. Okay, yes, anyone with the answer to the problem? Okay, Amida, you are welcome to class. Yes, do you have the answer? Your answer to the problem? Okay, I'm waiting for infinity answer this time around. Okay, is infinity still there? Okay, by now we should be rounding up. Yeah. Okay, what's happening? Nobody have dropped an answer. Nobody. Okay, we have to move forward because of our time. All right. Funke, do you have the answer? I can only see you saying hi. Okay. Okay, you want me to give you a minute? Okay. Okay, that should go for the whole class. All right. So we have less than a minute now to round up. Yes, by now we should be dropping an answer. Okay. While you are solving the problem, let's do it. You can later compare with what you have there. Now, I said something at the beginning of this class. Don't cram formula. Make sure you understand how the formula is derived. That will help you to be able to solve any problem given to you. All right, so you see this question now, you may begin to think of what formula will I use? What formula will I use? You may not need to use any formula here. Look at it. Now the question says an arc is 3/8 of the circumference of a circle, which has a radius 28 centimeters. So now what's the question saying? Now we have an arc. Say arc is 3/8 of what? Circumference of a circle. What's the formula for circumference of a circle? That is 2 pi r. 2 pi r. That's all. That's what the question is talking about. An arc is 3/8 of the circumference of a circle, which radius is 28. So that's all. So I just calculate the length of arc. So we just say length of arc now. Length of arc equals to 3/8. Now, of in mathematics means multiplication. So we say times 2 times 22/7 and times r. What is the radius? That's 28. That's all. So now what's the next thing? Now let's start dividing. Now let's see. 2 goes here, 4. 2 goes here, 1. Now 2 goes here, 2. 2 goes here is 14. 14 goes, 7 goes here, 1. 7 goes here is 2. 2 goes here, 1. 2 goes here, 1. So what are we left with? We are left with 3 and 22 in the numerator. So denominator will just have 1, 1. So that means our answer is going to be 3 times 22. And that gives us what? 66 centimeters. 66 centimeters. So this is the length of the arc in this question. That's the first part of the question. Can you see? That's simple. Now the next question now is the angle subtended at the center of the circle. The angle subtended at the center of the circle by the arc. Okay, now Can I give you 30 seconds now to quickly tell me what the answer is going to be? What's going to be the angle subtended by this arc, which length is 66? Okay, so can you try that? Let me give you a minute now to do that for me. So it's not so difficult. This time around, you can make use of the formula, right? Okay, all right. I'm just seeing Theos's answer. Okay. Did you give this one before we finally solve the problem? Yes. All right. Okay. Someone has given an answer to be 135. Yes. Is there another person? Yes. Another person? Mutiat Adebayo, you're welcome to class. I'm seeing you for the first time for today. All right. Can you attend to that question? Okay. So now, because of our time, let's solve the problem together. Now let's solve the problem together. Now to get the angle. Now, since we already know the length of the arc, so just write out the formula. Length of arc is theta over 360 times the circumference of the circle, that is 2 pi r. Okay, so now we know this to be 66. Theta is what we are looking for, 360 times 2 times 22 over 7 times, what is r? That's 14. No, 28, sorry, we have 28. Okay, so now we have this 7 goes here 1, 7 goes here is 4. All right, so 4 goes here is what? 90. 4 goes here is 1. Now 2 goes here is 45. 2 goes here is 1. Okay, another thing we can do here, we can divide both sides by 2 or by 11. Divide both sides by 11. Or let me write it out so that it won't look confusing. So now what we are left with here, we have 66 equals to theta times 22. Okay, we only have 22 in the numerator. What of denominator we have? 45. So you can cross multiply. So if you don't want to divide direct, okay, let's cross multiply. So we have 22 theta equals to 66 times 45. Don't be in a hurry to multiply this to have one big number like that. So you don't need to do that, just leave it that way. So here we have theta equals to 66 times 45 over 22. So as you can see now, 11 can go in 66 and it can also go in 22. So 11 goes here is 6, 11 goes here is 2. All right, so now we have theta. Okay, so now and 2 goes here. That's 1, 2 goes here is 3. So we have theta equals to 3 times 45. Can you see that now? And what is that? Theta is going to give you 135 degrees. So this is the answer to the problem. All right, so I think someone got the answer. That is curiosity. That's very good, very smart of you. I love that. So that is the angle subtended by the arc, which length is 66 centimeters. Okay, so your observation as regarding this solution, Any observation before we move down to the next question? Yes, any observation? Oh, any turn. I'm seeing you for the first time. You are welcome to class. Okay, so right. So why just joining the class? Um, yes, can we move on to the next class? Next question. Let's move down to the next question. Since we don't have any problem with this one that we just did. Okay. Okay, the next example. Okay, now let's look at the next question. The arc length, the arc length of a circle is equal to the radius of the circle. Now find the angle subtended at the center in degree. So that is the question. All right. So can we try that question? Let's try that question and let's see what we have for that. So what is the angle subtended at the center in degree? So now let's try it. Once you get your answer, please drop that in the comment section. So I'm waiting for your answer right now. Right? And don't forget, those of you that are just joining, you have not subscribed, ensure you subscribe. If you've not tapped the like button, make sure you do that if you love what we are doing here. Okay, so let me give you like 2 minutes to attend to that question. Let's see what we have. All right, okay, Anyton. Okay, you've been in the class, but I've not been seeing you participating. So if you're in class, I must see you participating. That's when I will know whether you're in class or not. Okay, no problem. You're welcome. Thank you for that. Okay. Yes, let's quickly attend to that question. Let's attend to that question. Let's see. So once you have the answer, drop in the comment section. Yes, is anybody with the answer? You have your answer. You drop in the, oh, Joseph have dropped an answer. That is 57.3, 57.3 degrees. Okay. Yes, any other person? Is it that the question is hard? I expect good number of us to be dropping answer. It's just only one person that dropped answer here. Okay. All right. Because of our time, now let's solve and let's see whether the answer given by Toyosi is correct. And if you have just gotten your answer, you can still drop that in the comment section. Let's see what we have. But let's look at the screen. Now, the arc length of a circle is equal in radius. It's equal to the radius of the circle. Okay, you understand that the length of an arc is equal to the radius of that circle. That's what the question is saying. So now the question now says that if we have such case, now what is going to be the angle subtended at the center of the circle by that arc in degrees? So I hope you understand the question now. We have a situation whereby the radius is equal to the length of arc. Do you understand? R is equal to length of arc. Now the question now is, what is the angle subtended by this arc, AB? All right. So we have it this way. We have R. So this R is the same thing as L. So we want to get this angle subtended at the center of the circle. So now let us write out the formula for length of an arc. So that is theta over 360 times the circumference of the circle, that is pi r. Okay. So now we have that the radius is also the same thing as what? As the length of arc. So that means we can write L equals to theta over 360 times 2 times 22 over 7 times L. Do you understand that? R is the same thing as L. So you can see what is changing now. So I'm changing this R to L. Okay, now let's try and simplify this right hand side. So now 2 goes here 1, 2 goes here is 180. 2 goes in 180 is 90. 2 goes here is 11. Can you see that? All right. So now let us now see what we have here. We have 11 L, which is the length of the arc, equals to 11 theta L over 90 times 7. Can you see that? So let us cross multiply. So we have 11 theta L equals to L times 90 times 7. Okay, so now what do we have next? So we have theta, because we're actually looking for theta. Theta equals to L times 90 times 7 all over 11 L. Okay. Do you get that now? So now this we can, so we have theta equals to over 11, and that is 9 times 7, that is 63 over 11. So what do we have when we divide that? Okay, so let's see, what do we have when you divide that? So that is going to give you 630 over 11. Okay, so when you divide that, you are going to have 57.3. Let's say 27 degrees, and that is approximately 57.3. So that is going to be the angle subtended at the center of the circle by this arc. Okay, so that is the answer. Any observation based on what we have done? Any question? Yes. Okay, I think that's the same thing with what Toyosi got. That's very smart of you. Yes, well done. That is correct. That's good. Okay, any observation? Do we all understand that? Okay. Okay, if there's no question again, so we are going to be stopping here for today. We have tried a lot, so we have looked at a lot of questions. So before we round up, make sure you tap the like button before you leave. Ensure you click on the subscription button if you are new. If you have not done so, please make sure you do that. And tomorrow is going to be another wonderful time. We are going to continue from where we stopped. Okay, so tomorrow, now look at what we have just done today. We have dwelt so much on finding lengths of an arc, finding angles subtended by an arc. So tomorrow we are going to learn how do we find perimeter of a sector, perimeter of a segment. So we are going to learn how to do that tomorrow. Make sure you don't miss the class. It's going to be interesting, and we are going to still solve more problem on this that are a little bit standard than the one we did here. Okay, so make sure you inform your friends, let them know about the class, and tell them how impactful this class is. All right, so I want to thank you, every one of you, those of you that just joined this platform. Yes, Infinity from Edian, you are welcome if you are still there. All right, so it's my pleasure meeting you. So, and others that are just joining. Okay, so make sure you extend this to your friends, your classmates. Okay, so thank you very much. Keep solving, and you will see, before you know what is happening, you are going to be a very good mathematics person. All right, okay, thank you very much. I love you guys. Bye bye.